Hi there. We're going to talk about reducing fractions. This is called Reducing Fractions Part 2, basically because we have already done some talking about reducing fractions, but we didn't go as far into it as we will today. So that's why it's Part 2. One of the things that we're going to use to reduce fractions that is kind of neat to use is prime factorization. And we just covered prime factorization like 2 lessons ago. So it's a good thing to use to reduce fractions. It's easy, and with downward division, it really is a snap. Okay? Now, we're going to use downward division and listing the prime factors to reduce this fraction. So we have 30 over 65 using downward division. 30 divided by 2 is 15, divided by 3 is 5, divided by 5 is 1. 1 we don't worry about. 65, it is not even, and it can't be divided by 3, so our next number is 5. And lo and behold, 5 goes into it 13 times, and that's it. I mean, that's the whole prime factorization. So if you write it down here, you have, for 30, 2 times 3 times 5, and that's on the top. And on the bottom, you have 5 times 13. The only common numbers between these two prime factorizations are the 5s. So you get rid of the 5s, and you're left with 2 times 3, which is 6, over the 13, which is what is left. And there is your reduced fraction. Now this is a pretty solid way to do it, and you don't make mistakes generally as easily this way. Let's look at 9 over 30. We'll use prime factorization. 3 goes into 9 3 times. 3 times 3 is 9, so that's pretty easy. 2 goes into 30 15 times. 3 goes into 15 5 times. And 5 goes into 5 once, and you're done. Now, we have to list the factors, and I did that down here. Okay, so you end up with 3 times 3 on the top, which of course is your 9, and 2 times 3, which is your 6 times 5 is 30 on the bottom. Common to both the top and the bottom is only the 3. So you cross out the 3, you're left with 3 over 2 times 5. 3 over 10, reduced fraction. Pretty slick. It really works really nicely. Now, let's go to my next page. I've just got some others I want to show you. I hope these go pretty fast. What happens when you have big numbers? Ooh, they're hard to reduce. So it's kind of nice to have this method that you can do it. 20 over 63. You have 2 into 20, 10 times 2 and 10, 5 and 5, 1. 3 goes into 63, that's kind of an obvious one. 21 times, 3 goes into 21 7 times. There's your prime factorization. Remember, you always have your prime factorization. It goes down the side like this. So it's 3 times 3 times 7, and 2 times 2 times 5. Okay, we have 2 times 2 times 5 on the top, 3 times 3 times 7 on the bottom. Any commons? 2 in the bottom, 3 in the top, 5 in the bottom, 7 in the top? No, there are no common factors, so guess what your reduced is? Yep, you guessed it, 20 over 63. Even though it's huge, it can't be reduced, and we proved it. Okay, we can use this method to help us when we multiply fractions as well. And it actually works kind of cool, and it keeps you from making dumb mistakes. Okay? Remember, when you multiply fractions, you multiply straight across. So, this is what we're going to do. We've got 3 sevenths times 21 over 30. I'm just going to prime number the whole thing all the way across. So 3 times 1 is 3. So there's your 3. 3 times 7 is 21. 7, of course, sits by itself because it's already prime. 30 is 3 times 2 times 5. Put that on the bottom. You look for commons, and you can do some reducing before you even multiply. We've got a 3 on the top here, and we got a 3 on the bottom. 3 on the top, no more 3s. Got a 7 on the top and a 7 on the bottom. Is there anything else common between the two? Doesn't look like it, so we have 3 on the top over 2 times 5 on the bottom. So we end up with 3 over 2 times 5, which is 10. That's our reduced, and it's multiplied. Really kind of cool. Works really well, and it's pretty fast. Make sure the biggest thing about it is that you don't make mistakes with it very often. So that's kind of to your advantage. Let's do 9/16 times 2/3. Again, we have 3 times 3 is 9 times a 2. 16 is 2 times 2 times 2 times 2. Eventually you'll get these so you have them in your head. And then of course times 3. Now we have to look for commons. We have 3 in the top and a 3 over here. No more 3's in the bottom. We got a 2 in the top and a 2 down here. So what do we have left to multiply? Well, we've got this 3. So that stays on the top. And then on the bottom we have 2 and 2 and 2. So we have 2 times 2 times 2. 3 over 2 times 2 is 4, right? Times 2 is 8. And there is your multiplication problem, and we know it's right because we did it. Works really well. Okay, now this one is a little bigger. It's got 3 fractions to multiply, and we do the same thing. 2 times 2 times 2, there's your 8, times 3, times 1. 2 times 2 is 4, times 3 is 12. Times 2 times 2 is 4, times 2. Wow, got a lot of numbers in there. Let's get rid of some of them, shall we? Got a 2 on the top, 2 on the bottom, 2 on the top, 2 on the bottom, 2 on the top, another 2 on the bottom. No more 2's. We got a 3 on the top, 3 on the bottom. And that about eliminates it, doesn't it? We got 1 left on the top. We can put a 1 here. And we have a 2 here and a 2 there. So 2 times 2, guess what? The answer is 1/4. That is just so slick. It goes so fast. Okay, and here's another one that we can look at. And again, I went ahead and multiplied them out for you. 21 is 3 times 7. 15 is 3 times 5. 36, whew, that's 4 times 9, but it's 2 times 2, which is 4, times 3, which is 9. 63, 3 times 3 is 9 times 7 is 63. Again, we look for commons. Let's see. We got a 3 on the top, 3 on the bottom. We got a 7 on the top and a 7 on the bottom. We got a 3 on the top and another 3 on the bottom. No 5's except on the top. So we got a 5 here. So 5 goes on the top. We have 2 times 2 times 3 times 3. Okay, 2 times 2 is 4. Times 3 is 12. 12 times 3 is 36. So 5 over 36, and that is the answer. Wow, that's kind of nice. Now, this last page, I would bet you that a lot of you already have done this before, okay? And this is a method that a lot of people use to reduce. It's called cross reduction, and you reduce before you multiply without writing the prime factors, and this is another way to do it. We start out with 9/16 times 2/3, and we look to see there's a 3 in the bottom, and it can go into 9, and that goes 3 times. There's a 2 in the top, that goes into 16 8 times, and then 3 times 1 is 3, and 8 times 1 is 8, and you get 3/8. This one is very similar. You have 8/12 times 3/4, 4 goes into 8 twice, and then you have 3 goes into 12 4 times. But then you have 2/4, so you really should reduce it to the lowest you can. So then 2 goes into 2 1 time, 2 goes into 4 twice, you end up with 1/2. So 1 times 1 on the top, here and here, and 2 times 1 on the bottom, here and here, end up with 1/2 as your answer. Now I went through that pretty fast, so let's do one here. Okay, we have 5/8 times 3/10. 5 on the top goes into itself 1 time, but it goes into 10 twice. 3 doesn't go into anything in the bottom, so we are done. 1 times 3 over 8 times 2, 3 over 16. Okay, do another one quickly. We have 3/4 times 8/9. We have a 3 on the top, goes into 3 once, 3 goes into 9 3 times. We have a 4 on the bottom, it goes into itself once, but it goes into 8 twice. 1 times 2 on the top over 1 times 3 on the bottom. You end up with 2 over 3. This is an alternate method to writing out all the primes, and it works. Okay, the last one we're going to do. We have 1 over 2 times 4 over 7. 2 goes into 2 once. 2 goes into 4 twice. You end up 7 doesn't go into anything, so you're done. 1 times 2 over 1 times 7 equals 2 over 7. And that's the answer. So you have some choices here. You can use the prime factoring when you're a little bit confused, or you can use this cross reduction before you multiply. Both of them are effective. Both of them work. Hope you have a great day.